lecture 15 of CS 302 data structures. In this lecture, we are going to see one more linear data structure, popular data structure, which is queue. In this particular lecture, we are going to see what is a linear queue, what is the application of a queue in a real life, and along with that, we will be seeing the implementation of queue using array and linked list. So let us start with the lecture. So here are two very common examples from our real life which we often do. So standing in a line. So this is a line of people standing to get into a lift, and this is a line of people standing to withdraw cash from the ATM. Now what is the common feature in both of this? That if a new person wants to come and get into the lift, that person have to come and stand at the last person in the line. Similarly, if a person wants to come and withdraw cash, he has to come and stand at the last. That means he will be the last person in the line. So whenever a new person wants to add to this line, it happens at the end. Which end? The rear end. Why the rear end? Because the line starts from here and it ends here. Similarly, when a new person comes and wants to stand to withdraw cash, the addition of that person happens at the rear end. Similarly, if we look at the part where a person moves away from the line, so when this person gets into the lift, he will be removed from this list. So we can consider as a minus. So he will be removed, he or she will be removed from the list. Now what happens? The next in the line will be the first one in the line. So this is the first person. So this person gets into the line. So when this person gets into the line, then this second person occupies this place. So that means the deletion. So this is the deletion or the removal happens at the front end. So this is my front end of the line. At the front end of the line, the deletion or the removal takes place. So these are the properties, and what is the common terminology used for this kind of line? It is the queue. So it is known as the queue. So this is the queue of line where the addition of a new person happens at the rear end and the deletion happens at the front end. So queue is a very popular data structure which is often used in solving computer problems, and now we will be seeing a formal definition of queue. So let us start with the properties of queue. The first property is it is a linear data structure. So let us represent the queue in like this. We can also always do it like this. Now I am having 3 elements in my list, something like this. Now what happens? In a linear data structure, we know that whenever we try to access or search any elements, that should happen in the traversal in the data structure should happen in a linear or a sequential order. Here sequential doesn't mean that the elements have to be stored in a contiguous memory locations. Here sequential means one after the other. So there is a linear relationship between the elements. So if we look at this representation, we see that we can go in a sequential order or in a linear fashion in this particular list, and we can access the elements or search for the elements. And it also happens that in this case the traversal happens in a single. So if we are traversing, we can happen in a single go. So that's why it is known as a linear data structure. The second property is that it is an ADT. So we know that the definition of abstract data type tells that we are not concerned about how a particular data structure is implemented. We are rather concerned about the operations which are allowed on the data structure. So if I want to write some algorithms using queue, where there are the operations insertion and deletion, we simply write NQ or DQ rather than, so insertion means NQ and deletion means DQ. So we simply write NQ and the given value DQ like that. Whenever we are writing that, we are not concerned about how we are implementing a queue. Like stack, for queue also we can have two algorithms. One is using array and another is using a linked list. However, if you are using array or linked list, the algorithm for you having the application of queue will not show you the details about whether it is implemented using an array and linked list. That is the reason why queue is known as an abstract data type, where the operations, insertion, deletion, and other searching, traversing access are of main importance. And how we are going to implement the queue in any programming language is not of any concern for the who is writing the algorithm. It is a concern of the programmer. And that's why queue is known as an ADT. The third property is that it is known as a FIFO. FIFO, let us look at this example. So what happens here is that, so suppose I want to insert a new element now 40. So where it will be inserted? It will be inserted after 50. So till this place it is occupied. So the next empty place is this. So 40 will be inserted here. Now, this is the, in this list we see that 100 is the first element which was put. Now when we will be deleting from this queue, we will be start deleting from this queue, then 100 will be the first element to go out. So this will be removed. Similarly, the next element which will be removed is going to be 30, because that is the element which is inserted in the second place. So this keeps on repeating. So if you compare this with the example which we have discussed in like in a real life, so whenever some line of people are standing in a queue to get into a lift, the first person who has came and stood in the line will be the first one to enter the lift, and this process keeps on repeating. So that's why it is known as first in, first out. The fourth property is insertion and deletion happens at two ends. So like in this case, what we have seen is that whenever a new element 40 is going to be inserted, it is going to happen at this end, which is known as the rear end, that is the tail. So we can also talk of this part as the tail of the leaf queue. This is the tail of the queue. So insertion happens at the tail. So let me elaborate this part. So insertion in the queue takes place at the tail, and it is known as NQ. So whenever we are inserting element, that operation is known as NQ. And now we want to delete. So where the deletion will happen? The deletion will happen at the front of the queue. This is known as the front or the head of the queue. So this is the front end. So where the deletion will take place. So now we can write it like this. Deletion in the queue takes place at the head of the queue, and this is operation is known as DQ. DQ operation. So if we compare with stack till this point, So that's why I have written these two parts. One is the rear. Rear is for the insertion and the front pointer, which is for the deletion. Now, if we compare it with stack, so let us have a comparison of stack and queue. So first, the similarity. The similarity is that both are linear data structures and ADT. So these are the similarities between stack and queue. So they are linear data structures and both are ADT. Now what is the difference? Now if we talk about the difference, then in case of stack, so stack was known as LIFO. That means whichever elements was inserted at the last will be the first one to go out. Well, in case of queue, it is FIFO, that is the first element which was inserted will be the last element to go out, will be the first element to go out. Sorry. The second difference lies in the insertion and deletion takes place. So, in case of stack, it happens only at one end. In case of stack, insertion, both insertion and deletion happens at one end. And if we talk about a queue, then insertion and deletion happens at two ends. So I will just write it down. Insertion and deletion happens at two ends known as rear and front respectively. So these are the two differences between the stack and queue. So you should, if it comes in exam, you should be very clear. So if it gives about the comparison, comparison includes both the similarity and the difference. And it talks only about the difference, then these 2 points you have to mention. Now let us see where actually in the computer system queue is used. There are many applications of queue. I will be showing just a small example of that. Let us go through it. So let us see this example. So this is my music player and I have created a playlist, as you can see in this. So this is my playlist, which is initially empty. And you have all gone through this, so you can relate to this very nicely. Now I add one audio to my playlist. So you can see that it is the only audio file which is there in my playlist. Next, I add the second audio file. So this is my second audio file. And you see this is placed after my first audio file. And I add a third audio file C, and you can see that in which order it is done. So the first one is done, then the second one, then the third one. Now you know that when we add music to our playlist, in which order they will be played, it will be played in this order. So the first one which was added will be the first one to be played. The second one, which was the second music which was added, will be the second one, and so on. So whenever we add music or some music files to our playlist, or whenever we play music in a music player, or whenever we play movies in our movie player, then that happens in a sequential order, one after the other. And the first one which was added will be the first one to be played. And that internally is implemented with the help of the queue data structure. Now you may ask me that previously, ma'am, you have told me we have a button and we have a play button here. And then we have a forward and a backward button, and that was implemented using a linked list. True. Linked list implementation, as we have seen in case of a stack, that stack is an ADT which was implemented with the help of a linked list. And in linked list, we can have several operations, moving backward or moving forward. Similarly, in case whenever we are adding music to a playlist or a music player, that order in which it will be played is internally implemented with the help of a queue data structure. And the buttons which are there for moving backward and forward, that is with the help of a linked list. So you can go through this on your own. You can see several examples like this, and then it will be very clear to you. So this is one example in real life or in computer system where queue data structure is used. Apart from that, in computer system, queues are also used for process scheduling in operating system. So what is meant by a process? So I will just tell you a bit about that. So whenever we are running some kind of applications, the applications, they are known as application programs. So application programs, what are the application programs? Such as, for example, our Acrobat PDF viewer is an application program. Music player is an application program. Microsoft Word is an application program, and so on. So whenever we are opening the application programs, they have to run, and the CPU is the resource which is going to be allocated to each and every programs for running. Now, whenever a program is in execution, it becomes a process. So that becomes a process. So this is meant by a process. So whenever I talk about a process, it means basically any application program in execution. Execution means when it is running actually in the CPU. Now, whenever we have multiple processes like this, such as P1 process means P1 application program in execution, P2 process, P3 process like this. Now at that time, how the CPU is allocated to this process, it is not done in a random fashion. So what happens is that internally there is a queue data structure, and whenever a process comes, so this process comes at time instant T0. This process starts at time instant T1. This happens at T2, and this process keeps on repeating. And where T0 is less than T1, less than T2, that means P1 has came before P2, P2 has came before P3, and so on. Then the CPU is allocated to the process in this order in which the processes arrive in an operating system or arrives in the system. So queue data structure is very important in case of scheduling algorithms, where a queue is maintained where the processes comes and enters and waits until the CPU, how the process scheduling takes place, how the CPU is allocated, that is part of a different subject which is known as operating system, which you will be also learning. But what I am trying to tell here is that how the different subjects are interlinked with each other. So when we are studying operating system is not a standalone subject. With that, internally, the data structure is also highly involved. Because we have already seen that how in case of a computer music player, or whenever we are browsing through, how the linked list data structure is there involved. Whenever the processes are coming, it is getting stored. Whenever functions are getting called, it is stored in the system stack. And whenever the process scheduling takes place, the CPU, this is also known as a CPU scheduling. So process scheduling and CPU scheduling are one and the same terms, which means that whenever a new program starts, it comes and gets stored in a queue, internal queue, and based on the time of arrival of the processes, The insertion happens based on the time of arrival of the processes and how the CPU then allocates the resource for each process to keep running. So this is the application of queue in a real computer system. Now we will be going through the algorithms, how we can implement the NQ and the DQ operation using array and linkage. So let us go through it.